and welcome Mindsetters to this session of Grade 10 Learn Extra. Hope you guys are ready. You got your pens and pads out and you're going to make some notes. I'm Ty and I'm here with Claire, who's going to be taking us for today's session. So Claire, what are we doing today?
Doing grade 10 today. We're doing plans and models, Ty.
All right.
Looking at some volume stuff, some surface area, and going from there.
Okay, no problem. So Claire,
Cool.
while you make your way across
Cool,
the
thanks,
board, I'm
Ty.
going to tell the Mindsetters, by now you know the drill, yo. Okay, that was a horrible hip-hop thing. But anyway, you guys need to make sure you get on the page, get chatting, let me know what you guys are thinking. If you're lost anyway, if you need help, post. Let me know what you guys are thinking. Because if you don't post, I can't help you. And Claire can't help you either because we can't read your mind through the TV. So make sure you get on the Facebook page, let us know what you guys are thinking, www.facebook.com/learnextra. But on that note, this is where I hand over to Claire, who's going to continue the show. Claire, take it away.
Cool. Thanks, Ty. All right, guys. Before we start, I know that we've been looking at how many people have been looking at our Facebook page. And last week, we had 16,851 people. Ty, how are we doing this week?
We're actually doing really well. I'm excited. We've got 17,410 likes on the page. And on that note, I want to tell the Mindsetters, you know what? That's awesome. But if you want to see me dance and maybe take off my hat, make sure you get us to 20,000. So tell your friend to tell a friend to tell more friends to tell other friends to get on the page. But back to you, Claire.
Cool. So let's quickly just to kind of warm things up, kind of get into the groove of things. Let's find out how many more people have liked our page this week, right? So we're going to take last week, we're going to subtract it from our current value, which is 17,410. So grab your calculators quickly. So 17,410 minus last week, which was 16,851. Okay, so we're looking at another 559 people, okay, interested in our page, which is awesome, absolutely brilliant. Okay, right. So now that we've warmed up and we're ready and we're going to get started, okay, we're going to jump straight into our questions. All right, I said today that we're looking at plans and models, so looking at floor plans. We're going to be doing a little bit of area calculations, some volume calculations. So we're going to start off with something quite straightforward, and then we'll go from there. So question number 1. All right, so it says, study the floor plan of Jill's kitchen below. Notice that it's not drawn to scale, and answer the questions that follow. So question 1 says, A, calculate the area of the floor. Now, there are many different ways that we can do this. Okay, so I'm going to obviously try and go the most direct route possible, but if you've got another way and you want to see whether it's right or not, why not just mention it on the Facebook page? I'll kind of touch on 2 different methods that probably you guys would use, but as I said, we're going to try and first with the most direct route, because then obviously you're going to waste less time if you go there straight away. So, right. Okay, if we have a look at this floor, this is a bit of an irregular shape. It's not a straightforward rectangle, so we can't just simply say that it's going to be length times breadth. So the majority of you might want to try and divide this up into 3 different sections or 2 different sections. It depends on how you want to do it. My way of doing it is simply to look at the entire picture as a whole, okay, and say, well, other than this extra little part over here that seems to be missing, I'm going to be working out the big rectangle and then getting rid of that little extra piece that doesn't seem to be there. Okay, so my method, taking length times breadth of the big rectangle, working out the area of the small rectangle, and if we subtract the 2, then obviously that will leave us the area of the floor. All right, so calculating area of a rectangle. Okay, you should know by now that this is going to be area is equal to length times breadth. Okay, and then we're going to minus that other length times breadth. So in other words, this is the big rectangle, and that's the small rectangle. Okay, so looking at the dimensions of the floor. All right, we have the length as being 7 meters. We've got our width or our breadth as being 5 meters. So let's fill that in. So 7 meters by 5 meters. And then that little area that doesn't seem to be there, in other words, obviously it's just a different shape that they've used for their floor, has dimensions of 2.65 meters by 1.55 meters. Right? So subtracting that area, so 2.65 multiplied by 1.55. All right, so grabbing your calculators. Okay, I'll give you a minute. Grab those calculators. You can't do this without your calculator. Okay, so don't wait for me to write down the answer. Make sure that you've got your calculators with you and you're punching in the numbers at the same time as I am so that you can check whether or not you're getting the correct answer. Okay, so 7.7 multiplied by 5. Right, that's going to give us an answer of 35. Okay. Hey. Right, let's work out the area of the smaller rectangle. So 2.65 multiplied by 1.55. So 2.65 multiplied by 1.55. Right? Okay, remember that if it gives you an answer as a fraction, just remember that you need to press your SD button in order to change it into a decimal number. So the answer there, 4.1075 square meters. So 4.1075. Hey. All right. Okay, once again, grabbing your calculators. So remember what we're doing. Big rectangle minus a small rectangle is going to give us the floor area that we're working with. So 35 minus 4.1075. Okay, you can say 35 minus that, or you can use your answer button on your calculator also as a little bit of a shortcut. So what it'll do there is it'll pick up the answer, the last answer that you just calculated, and it'll use that in the calculation that you're doing now. So 35 minus the answer that I just calculated, and it gives me my answer as 30.8925. Right, now when we're working with decimal places, if they don't tell you what you need to do, make sure that you're rounding off to 2 decimal places. So even when you're matric final, when you eventually get there, in the very first instructions of your paper, it always indicates to you that where necessary, round off to 2 decimal places. So we're going to do that. Okay, so rounding off to 2 decimal places, that 2 is obviously going to leave that 9 the way it is. So the answer is going to be 30.89. Okay. Units, very important when we're dealing with maths literacy because obviously we're talking about a story. So it's not like maths where we're just number crunching. Here there's a story behind it, which obviously we have to have some form of unit involved. So obviously we're calculating area, which means it's going to be some form of square measurements. And because we were dealing with 7 meters and 5 meters, our unit will be square meters, okay, or meters squared. All right. Okay, just touching on one of the other methods that you could have done. So let's say you didn't like my method and you wanted to try and split the shape into different rectangles and add them all together, you can do that. So you might want to have drawn and said, I'm going to first work out the area of A, maybe split it down there, work out the area of B, and work out the area of C. And then once you've worked out all 3 areas, adding those 3 together, you should get the same answer. So there isn't one method of doing this. There is a few methods that you can obviously try. So if you've got a slightly different method, provided that you're still getting the answer of 30.89 square meters, then I'm pretty sure that there's nothing wrong with what you're doing. Okay. Right, jumping on to the next question. Okay, so we're looking at different types of ways that you can obviously cover your floor. So this person, Jill, says that she decides that she wants to replace the linoleum flooring in her kitchen with tiles. Okay, so instead of using the flooring that's currently there, they now decide that they want to re-tile the floor. The tiles that he has chosen are squares measuring 40 centimeters by 40 centimeters. So if you can visualize what that looks like, okay, your standard ruler length is 30 centimeters, so about 10 centimeters longer than that. That's roughly the size of the tile that they're going to use in order to tile the kitchen floor. Okay, question 1, calculate the area of each tile in meters squared. Okay, so bit of a multi-step question because the dimensions that are given to you in centimeters, and you obviously need to work out the area of it in meters squared, okay, or square meters. So the easiest way to do that, we need to convert those 40 centimeters into meters. Okay, so now you need to ask yourself a question. How many centimeters are there in a meter? Okay. Now, if you know a method to work with, or then obviously you can use that. The way I remember it is I think to myself, all right, I know that 3 rulers, those standard rulers, and a little bit more equals 1 meter. So 3 rulers is 30, 60, 90, plus another 10 centimeters gives me 100. So 100 centimeters equals 1 meter. So if I want to convert centimeters into meters, I have to divide each of those measurements by 100. Okay, so first thing, that's what we're going to do. We're going to take the 40, we're going to divide it by 100, and that's going to give us an answer of 0.4 meters. All right, so the length and the breadth of these tiles, because they're squares, they're 0.4 by 0.4 meters. Calculating your area. Still working with length times breadth. Okay, you can look at another method that they call length squared. That's also okay, because obviously the length and the breadth are the same. Length times breadth, 0.4 multiplied by 0.4. Okay, grab your calculators if you're not sure. If you can't do it in your head, make sure you use your calculator. Right? So 0.4 multiplied by 0.4, and that gives us an answer of 0.16 square meters. All right, nice and straightforward. Okay, let's have a look at the next question. All right, the next question says to us to calculate the number of tiles Jill will need to tile his kitchen based on your area calculations. So what they're asking us to do here is we know the total area of the floor that we're dealing with. We know the area of the tiles that we want to use. So we want to know how many tiles am I going to need in order to cover my kitchen floor. Okay, now there's two different methods, and we're going to look at the second one in a minute. But if I say to you the minimum number, I'm saying chances are the minimum number means we'll probably have to use, so if they don't fit perfectly, we might have to cut some of the tiles, okay, in order to kind of match up the areas that are not going to fit perfectly. So when they say minimum number of tiles, what they're simply saying is how many of your tiles are going to fit into your floor. So working out how many you're taking your area of your tiles and dividing it into your floor area. So going back to our previous page, we worked out that the area of the floor was 30.89 square meters. I want to know how many 0.16 meters squared there are in 30.89. Okay, so 30.89 is our area of our floor, so let's write that down. Okay, right, and I want to know how many 0.16s will go into that value. Okay, so grab your calculators again. Thank goodness for calculators. Right? So 30.89 dividing by 0.16. Okay? That's going to give us an answer of 193,0625. Okay, now we need to talk. Okay, we're talking about tiles, all right? So when you think about it, 193.0625 tiles, that doesn't really make much sense. Okay, we don't get 0.0625 of a tile. So when you're asked that question, you need to think to yourself, am I rounding up or am I rounding down? Okay, now normal maths rules will tell you if you're rounding off to the nearest whole number, that 0 is not going to change that 3. It's going to leave it at 193. Okay, but if you have 193 tiles, you're not going to have enough in order to cover the entire area. Okay, because there's going to be a gap somewhere. All right. So even though maths tells you that you need to be rounding that down, maths lit tells you I need an extra tile here to make sure that I cover the entire area. All right. So in that situation, instead of saying 193 tiles, we're going to round that up to 194 tiles. Okay. Good. All right, so that was the one method, taking the area of the floor, taking the area of the tile, and dividing the two. In other words, how many tiles will fit into my floor, all right? The next question says that when Jill speaks to the tiler, okay, so the person who's going to come and do the tiling, he uses the length and the breadth of the tile and the kitchen to estimate the number of tiles he needs. Explain why this is more practical calculation, right? So let's just go through that again. So once again, he said he's using the length, okay, and the breadth of the tile and the kitchen. Okay, so we need to be looking at those when we go back and have a look at our diagram. We need to go back and have a look at what the length and the breadth of those are. Okay, so let's just start off nice and straightforward. Okay, so difficult to work with because this is not a straightforward rectangle, but you can still do it even if you're just estimating. So what they're asking us here is, instead of working out the area of the one and working out the area of the other and dividing the two, so that was the one method that we dealt with, what they're saying now is the tiler is saying how many of my tiles will fit lengthways and how many of my tiles will fit into the width. Okay? And if I know that, I can then obviously then calculate how many tiles in total I'm going to need. Okay? So maybe if you're making some notes or you're drawing a little bit of a sketch, maybe just draw yourself one tile in so you get an idea of what we're looking at. So we're saying, if I have a tile, and we know that this is 0.4 by 0.4, I want to know how many of those are going to be fitting into the length of my floor. And in the same breath, I also want to know how many of them will fit in that direction. And if I can cover the entire floor, then I can work out how many tiles I'm going to need. Right. So we're going to start off, I'll do the length with you, and then I think you need to do the breadth by yourself. Okay? Extend yourself just a little bit. All right. So length of my floor is 7 meters. I want to find out how many tiles will fit in that way. So in other words, if the length of my floor is 7 meters and the length of my tile is 0.4 meters, how many 0.4s will fit into my length? So once again, on your calculator, if you work out 7 divided by 0.4, okay, that's going to give us an answer of 17.5. Okay. Think about it, 17.5 tiles. Yes, we can cut tiles, but generally speaking, if the tile is going to be buying the tiles, he's going to buy boxes and they're going to be complete tiles, and then he'll cut them when he needs to. So 17.5 tiles means I need to make provision for 18 tiles that are going to then fit across the length of my floor. So in this case, I'm going to round that up to 18 tiles. Okay. All right, so that was saying across the length of the floor, we're going to work with 18 tiles. Okay, so 18 tiles across the bottom. Okay, we're going to take a break in a minute. What I'd like you to do in that break is think about doing the exact same thing now if we're working with the breadth of the floor. In other words, we're now working with the 5 meters. How many of these tiles will now fit into the breadth? So exactly the same method as what we used to work out the length. Let's see if you can work out how many will fit into the breadth of the floor. Ty?
Well, thank you for actually telling the mindsetters about that, because we actually might need to take a break just now. I'm thinking, mindsetters, all I'm going to say is that, listen, you need to get on the page, get chatting to me. Right now, my page is malfunctioning on me because Facebook decided to say, hey, we decided to take a break today. But anyway, mindsetters, we're going to fix that. And while we're fixing that, you need to take a quick break, go grab something to drink, go grab something to eat. But we'll see you soon after this break. And welcome back, mindsetters. I hope you had a nice little break. You went and did whatever you had to do. You went to the bathroom. You went out to the phone. Now you need to pay attention and have your pens and pads out and ready to make notes. Because I'm going to hand over to Claire, who's going to continue the show. Claire, take it away.
Cool, thanks, Ty. Right, so in the break, I said to you that you needed to now work out how many tiles would fit into the width of the floor. So running through that pretty quickly then. Right, so 5 meters, that was our length of our, that was the length of our width, okay, or the width of the floor, better English. And we're going to divide that by 0.4. All right, so on your calculators, if you put that on your calculator, you should have got, all right, an answer of 12.5, right? So once again, you need to think to yourself, 12.5 tiles. If the tile is buying the box, he's not necessarily going to buy 12.5 tiles. He's going to buy a box that's going to have a complete number. So in this case, we're going to then round up to 13 tiles. Okay, right. So what have we calculated? So we know that there's 18 tiles that are going to fit into the length of our floor. We've now worked out that there are 13 tiles that will fit into the width. Okay, so 13 of those tiles going in that direction. Okay, and 18 in that direction. So we know now to work out how many tiles in total, if there's 18 rows, okay, and there's 13 columns, if you like, 18 multiplied by 13 is then going to tell us how many tiles we have in total. Right, so 18 multiplied by 13. Okay. Grab your calculators. Right, 18 multiplied by 13 gives us an answer of 234 tiles. make sure you tell the marker or the person who's going to be looking at your paper that we're dealing with, you understand that we're dealing with number of tiles. So just put that in there so that you can explain quite clearly that you know what you're talking about. All right. Now, we need to quickly talk about the difference in our questions, because when we worked with the area of the floor and we worked with the area of the tile, we worked out that we only needed 194 tiles. Okay. However, in this other method, we've calculated that we need 234 tiles. So if we look at the picture, right. Now, I know some of you are shouting at me and saying, oh, yeah, but that's because we included that little extra rectangle, so obviously there will be more tiles. Okay, but that's what we're going to do then is let's work out how many tiles would cover that area. Okay, we'll take that away, and we'll see then maybe they'll end up being the same as the previous answer, maybe not. Okay, so exactly the same way as what we did with the 7 and the 5, we're going to work with the 1.55 and the 2.65 meters. And I just want to work out how many tiles would cover that area over there, and we're going to get rid of those because we obviously don't need those because that's not actually part of the floor area. All right, so I'm going to do it over here, right next to the question so you can see what I'm doing. Okay, so we said already 1,55. If we divide that by 0.4, okay, and we get our answer. And we're going to do the same thing with the 2,65 divided by 0.4. And that'll tell us how many tiles, right? So we're trying to work out how many of the tiles will fit into that length over there and how many tiles will fit into the width. So grabbing your calculators, 1.55 divided by 0.4. All right? That tells us that we're looking at 3.875 tiles. Okay, using your common sense, you can't have 0.875 of a tile, so we're going to round up to the nearest whole number. So we're working with 4 tiles in that situation. If we get the other calculation, we said it was 2.65 divided by 0.4, right? And in that situation, you look at 6.625, which we're going to then round up to 7, all right? So this answer, when we rounded it up, was going to give us an answer of 4 tiles. And this gave us an answer of 7 tiles. Okay, so 7 tiles across the length, 4 tiles across the width. 7 multiplied by 4 is going to give us 28 tiles. Okay, so in that little block over there, all right, there's 28 tiles that I now don't need. So in this calculation that I worked out down the bottom, okay, which gave me my 234 tiles for the entire floor, 28 of those, I don't need those anymore, not part of the floor area, so we're going to take that away. So 234 minus 28 tiles. Okay, so grab your calculators. Right, 234 minus 28. Okay, gives us 206 tiles. All right, now let's talk. So, using the tilers method, we got 206 tiles. Using the previous method, we got 194 tiles. Okay, so now we need to ask ourselves the question is, why is there such a big difference between the two? Okay, so think about it. Okay, so what we did with the first one is it was almost like a theoretical method. We're saying if we cut up the tiles and we kind of made sure that all of our little gaps were covered using the extra tiles, then we've got a minimum of 194 tiles that we're going to need. Okay, but in terms of actually doing the building, okay, tilers don't really want to kind of cut up pieces of tiles. They're going to try and keep it as clean and as neat as possible. In other words, they're going to use whole tiles for as long as possible. And then if they get to, let's say, the edge of the floor and there's a tiny little gap where a whole tile won't fit in, well, then they're going to look at the extra tiles that they've got and then they're going to cut them and place them accordingly. Okay, but we don't really want kind of half a tile here, a quarter of a tile here, a third of a tile here. We want to try and keep it with the least amount of breaks and the least amount of kind of bitty areas as possible. Okay? So the difference between these two methods is the first one is simply saying if we do cut up all the little bits and pieces and we mishmatch them, in other words, we kind of do a little bit of a puzzle and stick them in the little areas, well, then you only need 194 tiles. The tile, on the other hand, is saying to be on the safe side, let's get 206. In that case, we don't have to worry about cutting and recutting. We only need to, let's say, make one cut per tile in order to make sure that we fill up all the gaps. Okay, so just something to think about. All right. We're going to have a look at another question in a minute that's very similar to this, except it looks at volume. Okay, so keep this kind of method in the back of your mind so that when we get to that question, you can then use the same logic in order to get to the correct answer. Okay. All right, something, now that was quite hardcore, that was quite hectic for the brain, so let's go for something a little bit light-hearted. All right. The next question that we're going to have a look at, this is something that's been introduced into your new system, your new department system. In other words, they're looking at maths is not just about crunching numbers, all right? So maths literacy is about reading instructions. It's about giving instructions, clear instructions to somebody. So you are not only involved with the numerical side, in other words, the math part, but you need to be literate as well. Okay, so maths literacy, combining the two together. So the next question that we're going to have a look at, okay, really cool little diagram, kind of takes me back to my childhood days with these little Lego men. All right, so it says that in question 2, some toys give instructions using drawings. Write down the steps to build this toy figure. Okay, so let's first just have a look at the actual drawing itself, and then from there we're then going to have to write down instructions on how we're going to put this Lego man together. Okay, so nice and straightforward. They've shown us the arrows on your picture. Okay, so looking at the arrows, they're kind of indicating to you where we're going to start, all right? So starting at the hat, moving on to the head, moving on to the body or the torso, and then into the leg area. Okay, so now when you're writing down steps for something like this, obviously this is a nice basic example. They could give you something a little bit more complicated, all right? Think about it as if you're explaining to your 5-year-old brother, okay, or your 6-year-old sister. In other words, you need to be very, very clear about what goes on to what goes on to what. So kind of like a foolproof method in order to put this thing together. So the more detail you give, that's fine. The more detail you give is better, because then there's no kind of questions as to say, well, what exactly did they mean by that? Okay, give clear instructions when you're writing down your steps. All right, so step number 1. Starting at the hat, because that's obviously the direction that we're working from. So starting from the hat, moving into the head, moving into the body, and then moving into the legs. So step number 1. Okay. So step number 1 for me, I would explain that we need to place the hat, okay, on the head. Okay, nice and straightforward. Step number 2. So once we've got the hats on the head, we're then going to put the head on the body. All right. So place the head. Okay, on the body. Okay. If you want to write down torso, that'll really impress your English teachers. Okay, torso meaning this part of your body, not your legs. All right. And then the last part is obviously in placing the torso, which now has the head and the hat on top of it, and we're going to place that on top of the legs. Okay, so place the body on the legs. Okay, so just summarizing that kind of a question. First thing you need to do is obviously look at the diagram itself. Okay, so you're making sure that you can see if there's any arrows or any special instructions already on the sketch. You're following those instructions in order to write down your steps for the assembly. Okay, cool, nice and straightforward. Right, okay, next question, a little bit more challenging. Keep in mind what we've done so far. Okay, so the ideas that we've done so far. Let's have a look at the next question. All right. Question 3 says, Jabu has to pack cylindrical cans into boxes. Okay, so cylindrical cans into boxes. The cans have a diameter of 8 centimeters and a height of 11 centimeters. And the boxes measure 66 centimeters by 33 centimeters by 13 centimeters. Okay, quite a bit of information given in that question. So make sure that you've got your highlighter and you've got your ruler or whatever, and you're highlighting the keywords in the question so you can focus on what's important. So quite nice of them. They've given us a little diagram to see what are we actually talking about. So we've got the dimensions of the box, so 66 centimeters by 33 centimeters. And we've got our cylindrical cans, obviously, that are now going to be packed within the box. Okay, so question 1, or question A, says, how many cans can be packed into a box using the arrangement above? Now, I've kind of brought a can along today so you can get an idea of what we're actually talking about. So there's obviously different ways you can pack something into a box. So in most cases, most cans will be packed on their circular bases, because if we tip it to one side, we don't want anything to fall out, right? But we could if we wanted to. So we can either pack it so if it's standing on our cylindrical base, or we can turn it and we can lie them down and pack them in that direction. So we need to obviously look at both different ways of packing the cans into the box, and then decide, well, which one's going to allow us to pack more cans into the box. Right. So the first way we're going to have a look at is if it is actually standing on the cylindrical base. Okay. So in this case, again, imagining that they're basically packed next to each other, okay, along like that, packed behind each other, and if necessary, they could even be packed on top of each other. All right. Okay. So when we did our tiling question, we started off by saying, all right, I need to figure out how many of these things will fit into the length and how many of them will fit into the breadth. And then lastly, because now we're looking at a three-dimensional shape, how many will fit on top of each other. So taking the dimensions of your cylinder, taking the dimensions of the box, I want us to find out how many of these diameters will fit into the length of my box. So 66 centimeters. Right, so 66 centimeters. If we look at the diameter, okay, they've specifically told us that the diameter in this case is 8 centimeters. All right, so we want to know how many 8 centimeters are going to fit into my 66. So 66 divided by 8, okay. Right, okay, now we need to ask ourselves a question, because in the last question that we did, we had to make a decision about whether we need to round up or we need to round down. Okay, so because in the last question we were wondering how many tiles we need, we obviously try and buy more in order to make sure that we have enough to cover the floor area. Now in this question, it's asking you how many cans are going to fit into the box. So if the answer comes out to be 8.25 cans, it's saying that that last can, okay, the 9th can, if you want to put it that way, it's not going to fit. So in this situation, instead of rounding up to the nearest whole number, the context is telling us that we're not going to be able to fit that many cans into the length of the box, so we need to be rounding it down. So 8 full cans will fit, and then obviously we'll just have a slight bit of space left over. So in this situation, we're going to work with 8 cans. Okay. Right, so that's saying that 8 of those, all right, 1, 2, 3, 4, 5, 6, 7, 8. Right, so 8 of those will be fitting into the length. Quickly work out on your calculator how many are going to fit into my breadth. So once again, you were still working with the diameter. Okay, so we're still working with the 8 centimeters, because remember, when you're working with diameter, it doesn't matter whether I turn the can to the front or to the back, it's still going to be 8 centimeters in width, if you want to put it that way. So the diameter is still going to be 8 centimeters. So on your calculators, 33 centimeters divided by 8. So how many cans are going to fit widthwise? So 33 centimeters divided by 8. Okay, 4.125. So thinking about that, 4.125, it's saying that 4 will definitely fit, but that 5th can isn't going to fit. Doesn't matter how much you squeeze and you kick and you push, it's still not going to be able to put inside that box. So in this case, we're working with 4 cans. All right. So what have we worked out? We've worked that we can have 8 across in the length. We're now going to have 4 within the width, all right, so 8 by 4, and then obviously we'd fill this up, okay, I'm not going to draw them all in, but you get the idea that we'll have 4 rows with 8 cans in each row. Now, that's all very well if we were dealing with area, but in this case, we're dealing with volume. So now you need to think about a third dimension, and you think to yourself, well, how deep is my box? Am I going to be able to fit another can on top of, in other words, put 2 cans on top of each other? Is there just enough space in order to put 1 can in? Okay. So in that situation, you need to be looking at the height of your cylinder. So just drawing a quick sketch, we know that that distance over there is obviously going to be 8 centimeters. Okay. And the height of this can is 11 centimeters because they told us that's in the question. Right. The height of the box is 13 centimeters. So I shouldn't have to do a calculation. Visualizing, if the box is 13 centimeters deep and the can is 11 centimeters deep, there's no way I'm going to be able to put 2 cans on top of each other because they're going to stick out the box. All right? So in this situation, we're just going to have 1 layer of cans within this box. All right? So, okay, I'm going to jump down to the bottom. So we said 8 cans across the length, 4 cans across the breadth, and 1 layer deep, which means that the number of cans that we're working with, okay, so number of cans is going to be 8 by 4 by 1. All right? And on your calculators, or if you just know your times tables, 8 multiplied by 4 gives us 32, and 32 multiplied by 1 is going to give us 32 cans. Okay. All right. We're going to take a quick break. Okay, so quickly go grab yourself something to drink. Ta.
All right. As she said, which is technically what I'm supposed to say, well, Claire, you're trying to take my job too. I know you're here to teach, but come on. But anyway, mindset is, as I said, make sure that you guys come back always, always, always. Go do whatever you have to do. If you have to go put your bags away, if you have to go change out a uniform, whatever, make it snappy, because we'll be right back after this break. And welcome back, Mindsetters. Hope you had a nice little break there. And as I said, you did whatever you had to do, and now you're back, you're focused, you're ready, and you're paying attention. Got your pens, pads out, and you're going to make some notes. Because I'm loving what's happening on the page. Just want to say thank you. And again, I'm going to say a little wave to Stephanie. She's always on the page. So I just say, you know what? Thank you for posting. On that note, this is where I hand over to Claire. Claire, take it away.
Cool. Thanks, Ha. All right. So in the break, hopefully you've got something to kind of get you going through our last little segment. All right. Seems like a little bit of a trivial question when you think about packing cans into a box, all right? But remember that this is going to apply to various different areas of your life, not just packing cans, okay? So I always tell my learners that you don't want to look like the dog who accidentally tries to squish in the extra can when you know that it shouldn't fit, okay? So yes, it's a trivial question, but it's a pretty good thing to think about because you never know when your image is going to be on the line. So next question says, are there any other alternate ways in order to pack the tins into the box? So we said already, standing them on their circular base and packing them according to that kind of dimensions or according to that arrangement. The other method, instead of taking the can and packing it this direction, we can turn it so we can pack it this direction. Not common, okay? In most cases, obviously, it's just that's the kind of the standard way to do it. There's nothing wrong with saying that we can't turn it on its side, especially when we're trying to think about how many, we want to try and get the most amount of cans that we possibly can into this box, okay, to maximize or to minimize our costs. Right, so the next question says, are there any alternate ways to pack the tins into the box? Yep, there are. All right, so let's quickly have a look. So the other way to do it, I'm just going to draw a little sketch so that you understand what I mean. All right. So the other way to do it would obviously to be packing it in that direction instead of packing it on the cylinder base. Right. Question C says, which method of packing allows you to pack the most tins into each box? Okay, so we can't make a conclusion until we've actually worked out how many will fit if we turn them on their side and we calculate how many tins there are. So we already know that in the other situation that we managed to fit 32 cans into the box. Okay, now turning them on their side, can we fit any more? Or are we going to fit less? Let's find out. All right. So drawing a quick sketch, we know that the height was 11 centimeters. So obviously now, because it's lying on its side, we're dealing with a length instead of a height, okay, because it's lying down. And then the diameter, which was 8 centimeters. Okay. Looking at our box. All right. So our box was 66 centimeters by 33 by 13. Okay, so let's just draw another quick sketch. So 66 centimeters in length. All right. 33 centimeters in breadth. Okay, and then a height of 13 centimeters. Okay, so taking the cylinder now, and I'm basically saying how many will fit in that direction. Right. Okay, so similar to what we've done before, the idea of how many will fit lengthways, so we're going to take 66, and now we're going to divide it by 11 instead of dividing it by 8, because obviously now we're working with the height of the can instead. So 66 divided by 11, that one's pretty straightforward, so we should be able to do that one. So 66 divided by 11, that means that we're going to fit 6 cans perfectly. Okay, so no decimals involved in this situation. Nice whole number to work with, right? So 66 divided by 11 gives us 6 cans. Okay, now looking at your breadth and looking at your height. So the cylinder now is facing a different direction, which means that our diameter, we're trying to figure out how many 8 centimeters will fit within our 33 centimeter width of the box. So 33 divided by 8, okay, on your calculators. So 33 divided by 8, okay, it's going to give us 4.125. So how many will fit exactly? Well, 4 will fit, and then we'll have a little bit of space left over. Okay. And then the last thing to think about is, are we going to have more than one layer if we do it this direction? So we've got 13 centimeters, we've got a diameter of 8. Obviously my sketch isn't drawn to scale, it's just a sketch. So 13 centimeters, each one of those is going to be 8 centimeters. Will more than one 8 centimeter fit into 13? Okay, if you know it straight away, obviously you can write it down. If you don't know, we're going to work out 13 divided by 8. Okay, so on your calculators, 13 divided by 8, right, 1.625. So once again, we can't fit 2, okay, because 2 we would have to have a minimum of 16 centimeters, and we only have 13. So in this case, once again, we're only going to be able to have one layer of cans. Okay, so one can, okay, in terms of how many will fit into the height. Right, so how are we packing these things? We're going to put 6 across the bottom. It's going to be 4 cans deep, and it's going to be 1 layer high. And if we work out how many cans that is, all right, we're going to work out 6 multiplied by 4 multiplied by 1. Okay. So number of cans. Gives us 6 multiplied by 4 multiplied by 1. Okay, 6 times 4 is going to give us 24. 24 multiplied by 1 is going to give us 24 cans. All right, going back to the question. Sometimes we forget that. Okay, forget to go back to the question and actually read what did they actually ask me. I did a whole bunch of calculations, and now I don't actually remember what the original question was. So which method of packing allows you to pack the most into each box? So we've looked now at 2 different methods. The first method gave us 32 cans within the box, and the other one gave us 24 cans within the box. All right, so explaining now which method. So if you're going to say method 1, then you needed to explain to me that that previous method was method 1 and this is method 2. What I would do is explain how you've packaged it. In other words, did you lie it down on its side, or did you stand it up on its circular base? All right, so for me to answer the question nicely, okay, so that the marker knows exactly what you're talking about, I would say that, okay, so the most effective method, or the one that's going to give us, okay, the method that's going to give us the most tins within the box. Okay, so the method, okay, so the method of standing, okay, the box, oh, hang on a second, standing the can, not the box. Okay, standing the can on its cylinder base, or circular base, on its circular base. Okay, we'll fit more cans into the box. All right. So, as I said, very similar question to the one when it came to working out the area of the floor. Okay, and that was obviously taking each of the dimensions of your can and working with the dimensions of the box in order to work out how many cans are going to fit into the box. Cool. Okay, the next question we're going to have a quick look at. We're just going to talk it through. We're not going to do all the calculations because, as said once before, they're all very similar. Obviously, the measurements are slightly different in each question, and the context is slightly different, but each one kind of uses the same idea over and over again, so you can keep practicing it to see whether you've got it right. Okay, so just quickly reading through the question. Okay, so now we've gone from having floor areas to putting cans into boxes. Now we've got boxes and we want to know how we're going to fit it onto shelves. All right, so when you read the question again, take note of the measurements of your box, take note of the measurements of the shelf, and then from there you're then going to need to decide, how am I going to arrange these boxes so that I can fit the most amount of boxes on the shelf without leaving any space. Okay, all right, I'm going to jump ahead a little bit. Okay, I think we've done quite a lot of that stuff. So let's look at something a little bit less of the same. Okay, something that hopefully you'll be a little bit more interested in, and that is shopping, because let's be honest, we're all interested in that. Okay, something that they give you is known as a floor plan or a shop layout, and they kind of ask you a few questions on that. So I'm just going to take a minute just to kind of look at, well, what are they actually showing us in this question? So if we just have a look, we've got something that maybe you're familiar with. They're showing us that we've got the shop CNA, we've got the shop Stutterfords, we've got Checkers Hyper, we've got the Woolworths sign. Okay, so if you recognize the Woolworths sign. And then there's some other symbols here and there that they indicate. So if you've never seen this before, or you've never gone to one of those information boards in a shopping center to try and find out where you are, because sometimes that happens and you have no clue where you are and you need to find out. Okay, just some of the symbols that they like to use. All right, that little symbol that looks like a funky little squiggle, all right, that's indicating that that's an escalator. In other words, they're saying that the shop has got 2 floors, so you'll probably need to take an escalator to move between the floors. Very important sign, okay, the loo sign. Everyone knows you need to be able to recognize that sign in case you're in dire straits. Okay. Shop numbers, okay, something else that you need to have a look at. So in this case, we're looking at something like L52. That's indicating that the shop is on the lower floor and that it's the shop number 5052. Okay, so kind of run out of time because we've been so hectically involved with calculating how many cans get into the box. Okay, so hope that today's been pretty useful for you in terms of thinking outside of the box instead of just what you normally do. I'm going to hand it back to you. Ta.
All right. So, what I'm going to say now is that I was actually thinking, like, maybe what we should do next time is, like, to get mindsetters, because I know it's all about relevance. So I was thinking next time we need to have an example of, like, how many PlayStation boxes can I fit into my room? You know, something like that. Work around that, you know, mindsetters. Give us suggestions. Like, if you want examples that are more relevant to you guys, post on the page. Let us know. That's why the page is there. You need to let us know. So make sure you talk to each other. Like I always say, mindsetters, if you see a mindset in trouble, make sure you help them out. And guys, just post. It's a forum for you guys to make sure that you can communicate with each other, not just with us here on at the schools. And on top of that, make sure that you check out the pictures and all the albums and stuff of the artworks and of the photos, because those photos can be used them as diagrams. But for me, this is where I then sign off and say thank you very much for joining us today. I'm Ty, and we'll see you next time. Cheers.